All right, so today's lesson is the first lesson of our trig unit on angles. This is 7.1a, and our topic today is angles, how we measure them in degrees or radians. And so your essential question today, when you walk out, you should be able to answer this question. How do I convert angle measurements in radians, degrees, and in degrees, minutes, seconds, which is a more finite and precise way to measure degrees, minutes, and seconds. So first, let's remember a couple of things. When we're talking about degrees and radians, remember that 2 pi radians is equal to 360 degrees. This is the thing you must remember. 2 pi radians is equal to 360 degrees. And remember also that we don't label radians with radians, and there's no symbol to replace the term radians. They're just radians. 2 pi radians is 360 degrees. So I can manipulate and write proportions or portions of this statement. This is a very powerful one. This is the most popular one. One revolution, one full rotation is 2 pi radians or 360 degrees. But the other ones that are really important to remember, that 180 degrees. Now, what all I'm doing here is I am finding smaller portions of this statement. So what did I do to 360 degrees to get it to 180 degrees? I divided by 2. So what is 2 pi divided by 2? Pi. And so I'm just writing alternate versions of the same statement, true statement. So what if I wanted 1 degree? How would I write 1 degree in form or in terms of radians? What did I do to 180 degrees to get it all the way down to 1 degree? I divided by 180. So on both sides, I would have to divide by 180 degrees. So 1 degree is the same thing as pi divided by 180 degrees. Okay? And then the other one that's really important for us to remember is this one. If I have 1 radian, what's that like in terms of degrees? And I mean exact degrees, not the approximate 57 degrees and some change. I'm talking about the exact answer. So how do I go from 2 pi equals 360 degrees all the way down to 1? What did I divide my radians by to get 1 radian? Divided by 2 pi. So I go, all right, so I'm going to divide by 2 pi, divide by 2 pi. So that's 1, and that's 180 degrees over pi. So 180 degrees over pi. So these are the really popular ones, and the one that's really important for you to just know is the first one that I talked about, and then the other ones you can find on your own. You can absolutely find on your own by going through that process. Okay, so here's something that will be very helpful as you're working through this entire semester, is how to convert back and forth between degrees and radians efficiently. So if I'm going to go from radians to degrees, what I'll do is I'll take whatever the measure of the angle is, so theta, whatever theta is, and if I want to convert that from theta radians to degrees, what I'll do is I'll multiply it times 180 degrees over pi. It's just this conversion right here. Pi radians times 180 degrees over, not pi radians, just theta radians. Okay, so that'll be the conversion if we're going that way. If we're going the other way, degrees converting to radians. So let's say we go with, all right, this is whatever the measure is, theta degrees. Definitely in degrees because it's got the degree mark. and I want to convert that to radians, I like to use dimensional analysis or unit analysis. I want to cancel out that degree symbol. So what I'll do is make sure that my degrees, 180 degrees, is in the denominator, because I would like to be able to cross simplify and cancel out the unit degrees. So, like so, cross simplify. And that'll convert it from degrees to radians. And I had to tell you, very often in trig, we do a unit analysis or a dimensional analysis, and we will cross simplify units of measure, whatever they are, feet, inches, miles, degrees. Okay? So you need to be able to remember which one you're supposed to use, 180 over pi or pi over 180. So I remember I always start with, what do I want? Do I want degree in my answer, or do I want degree not in my answer? So how could you remember? What could you do to remind yourself? What do you think? So what if I said 60 degrees and I wanted you to convert that to radians? What would I use? And why did you choose pi over 180 and not 180 over pi? So you can cross out the degrees. Exactly. Exactly. So good eye. All right. And what if I wanted to go this way? 3 radians, and I wanted to convert that to degrees. I'll do 3 pi radians. There you go. I'll make it even simpler. 180 over pi. So what can I do? Cancel out the pi and get my answers in degrees. So that might be a helpful little tip for you guys. All right, so let's do a little practice. Here we have 2 sets of problems here. It says the first set of instructions, find the exact radian measure of the angle. So we have 450 degrees, and we want to write that in radians. How many radians is that? So what are we going to do to convert? Pi over 180 degrees. And I think we could do a real quick cross simplification. I'm going to grab my blue pen here so we can cancel. That's not blue. Give me my blue pen. Thank you. So we're canceling out our degrees, converting to radians. And I think I can cross simplify 180 and 45. 90 goes into both of those, 2 and 5. So that gives me an exact measure of 5 pi over 2, or 2.5 pi. Those are both exact answers. Decimal and fraction form doesn't matter. Exact. You do the next one. Okay, so you're taking negative 72, multiplying it times pi over 180 degrees. So you can cross cancel out your degree measures, and you get negative 2 pi over 5, or negative 4/10 pi. Either one is acceptable. All right, now we're going to go the other way. Find the exact degree measure of the angle. And these angles are given to you in what unit of measure? Radians, because there's no unit. So we're going to assume radians. So if we want to change it to degrees, what are we going to multiply by? 180 degrees over pi. That way we can use our unit analysis, cancel out our pi's. Come on, red pen, cooperate. And then I think 2 goes into 180 degrees. So negative 7 times 90, negative 630 degrees. And these little calculators will quickly give you that answer. Okay, there's the next one. You do that one. Okay, so we're multiplying again by 180 degrees over pi so that we can cross simplify, get rid of the pi, convert to degrees. Did a little more cross simplification. We have the solution 495 degrees. Okay, so Really important skill that you've got to pick up. And having your little calculator is really handy if you have it in math print mode. Okay. All right, let's move on to coterminal angles. Remind me, what are coterminal angles?
Angles that share a terminal side.
Angles that share a terminal side. So yesterday we talked a little bit about them, but we didn't put the, and we looked at them, but we didn't look at them on the same graph. So first, let's go ahead and read the instructions so that what I'm about to do up here in this white space in my explanation or my demonstration makes more sense. It says, if the given angle is in standard position, find two positive and two negative coterminal angles. Also, let's just cancel C out. We're not going to do that. Omit C. Okay, so we have to find two positive coterminal angles and two negative coterminal angles. So here's an example. Let's say up here, I have a coordinate plane, and on my coordinate plane, I graph a 30-degree angle. And I think I'm going to zoom in a little bit here so that we can see this a little better. All right, so this is a 30-degree angle. And I could also talk about it in radians. So I could also say that this is pi over 6 radians. Now, if I want to find angles that are coterminal to this 30-degree angle here, a coterminal angle has to have its terminal side on in exactly the same position. So it will look exactly like that angle right there. Same initial side, same terminal side, but different measure. And it has to be positive. So what could I do? Here's something I could do. I could start on, I have to go positive, so that means starting at initial, positive y-x-axis, I'm going to rotate up. I can rotate a full revolution and then come back up and rest right there on the same terminal side. But that's not a 30-degree angle. That's a 390-degree angle because I did one full revolution plus an additional 30 degrees. And that's certainly not the only positive coterminal angle that I could have here. I could do 2 full revolutions. I could do 1,000,000 revolutions. There are infinite positive coterminal angles to 30 degrees. I only want 2, so let's not be too crazy about that. But let's also, what if we had to find this measure not in degrees but in radians? If this is pi over 6 radians and I want 390 degrees, but I want it in radians, what could I do? Could I convert it quickly? I could go, all right, so 390 times pi over 180. I could do that, right? Or could I just add 2 pi to pi over 6? That's something else I could do. It's up to you what you want to do. Doesn't matter to me. I think I'm just going to say that this is 13 pi over 6 because one full revolution is 12 pi over 6, right? 2 pi is the same as 12 pi over 6. They're the same. And then that's just one additional pi over 6. So how could I go about just writing a general statement that would help me do whatever measure I'm given that I could quickly find 2 coterminal angles? Here's what we're going to do. We're going to start with theta degrees, whatever the measure is in degrees. First we'll do degrees. And to find coterminal, we just add 360 degrees times some number of revolutions. Maybe you do 1 revolution plus 360, or you do 2 revolutions plus 720, etc. Certainly up to you if you want to do that. But that's if the measurement's given to you in degrees. If it's given to you in radians, angle theta, then instead we would add not 360 degrees, but 2 pi times however many numbers of revolutions we choose. All of them, because we're adding 360 degrees, unless we're starting with a very negative value, will be positive angles. So those are positive coterminals. So that's a positive example. Let's do a negative example. So, and we'll start with the same measure. We'll start with the initial, or this angle here, red pen, at 30 degrees, or pi over 6 radians. And we're going to find some negative coterminals. So what would I do? If it's negative, clockwise from my initial position, right? And the angle has to be exactly the same. Same initial side, same terminal side, but in a negative action, I would be from the starting point clockwise. So what's the measure of that angle? Because that's not one full revolution, right? It's like a revolution minus 30 degrees, but it's negative. So it's negative 330 degrees. Negative 330 degrees. That's certainly not the only one. I could continue to go in a negative spiral and add revolutions to that. I'm just adding negative revolutions instead of positive. All right. What about if I were writing it in radians? Two pi, right? If I'm going to write it in pi over 6 is equivalent to 12 pi over 6. Am I right or wrong? So if I want to find the radians of negative 330 degrees, couldn't I just do 12 pi over 6 minus 1 pi over 6? Which would be a negative 11 pi over 6. Or I could use my conversion if I choose. You're mathematicians, you choose what works for you. So what could be our generalized statement? If we're finding negative coterminal angles, we're going to start with theta degrees, and we're going to subtract 360 times the number of revolutions because we're going in a negative action, and make sure that says 360 degrees, because if we forget, I can say words sometimes, forget degrees, and we're saying radians. Or theta radians minus 2 pi times the number of revolutions. Just remember that you always start on the given angle, and you either add 360 or you subtract 360. So let's give it a try. Here we have two angles. Angle A is 620 degrees, and you have to find two positive and two negative coterminals. So let's start with positive. So if we start with 620 degrees and we add 360 degrees, a coterminal angle would be 980 degrees. Okay, so we could consider that one positive coterminal angle. How could we quickly find another one? Add another 360, which would be a second revolution, and that would give us 1340 degrees. So that's a really efficient way to find two positive coterminal angles. Now let's do two negative coterminal angles. So if we start with 620 degrees, what shall we do? Subtract 360. Okay, but wait a second. That's not a negative angle. 620 minus 360, what is that? It's negative 260? Negative 2, what is it? Do the math. Where's the calculators? Positive 260 degrees. That's not a negative angle. That's not a negative angle. So we're not at negative yet. So we'll have to subtract another 360 degrees to get our first negative coterminal angle. So there's one. You have to be really thoughtful here and think. It's got to be a negative coterminal angle, so it has to be a negative value. And then we could continue to subtract 360 degrees And that would take us to a negative 460 degrees. So I would just say to be really careful. When you're asked for a negative coterminal, it should be a negative angle. So here's what I know then. If I were being thoughtful, I could say that this 260 is another version or another option for a positive coterminal angle, but not one that we would typically think about. But it is. So something to think about there. All right, let's do these this one here, 2 pi over 3. So this is in radians. So we'll be adding 2 pi or subtracting 2 pi. So let's start with our positives. So we're going to go, all right, so 2 pi over 3. And what we want to do is add a full revolution. So we're going to add 2 pi. But you know, can't really add those without my calculator or my fraction skills. So shall I put that 3 over 3 times 3 over 3? And I'll move that forward to 2 pi over 3 plus 6 pi over 3. All right, so that'll give me my first positive coterminal angle of 8 pi over 3 radians. So I'm just adding 2 pi, but with the right denominator. And then I can just add 6 pi over 3 again, and that will give me 14 pi over 3 radians. That's my second coterminal. And then if I want to find the negatives, well, I think I would just subtract 6 pi over 3 instead. So 2 pi over 3 minus 6 pi over 3 would give you negative 4 pi over 3. And that would be one negative coterminal. And then subtract another 6 pi over 3. And that would give you a negative 10 pi over 3 radians. And that would give you two options. Again, infinite options for both of them. But why complicate your life by doing many revolutions? Okay, do you have any questions about that? All right. Then what we'll do now is move on to the back side of our note page. And we're going to talk a little bit about, I haven't talked about it yet, degrees, minutes, and seconds, or DMS. So this is degrees, which is notated with the degree mark. Minutes, which is notated with a hash. And seconds, which is notated with a double hash. So a lot of times you'll see it in degrees, minutes, and seconds. And minutes and seconds are just smaller increments of a degree. And they're very similar to minutes and seconds on a clock. So here's what you need to know. We want to be really precise with some tools that are used in life. And when we're finding 17.2598 degrees, sometimes it's easier to convert that to degrees, minutes, and seconds so that we can get a more precise measure. So here's what you need to know. 1 degree is equal to 60 minutes. And 1 minute is equal to 60 seconds. So you can kind of think of degrees like hours in regards to minutes and seconds. But know that there are not 360 hours in a circle, right? There's only 12 hours in a circle. So don't confuse it too much. Conversely, so what you need to remember is there's 1 degree is equal to 60 minutes and 1 minute is equal to 60 seconds. And conversely, sometimes it's more important to be able to go the opposite direction. Conversely. There we go. I can spell that word. 1 minute is equal to 1/60th of a degree. So if I'm going from minutes to degrees, I like to use this version. When I'm going from degrees to degree minutes and seconds, I use the first conversions. And 1 second is equal to 1/60th of a minute, and it's also equal to 1/3600th of a degree. So this we'll use when we're converting to degrees, minutes, and seconds. So we could make ourselves a little note right here. Use when converting to degrees, minutes, seconds. And then we'll use this other one when converting to degrees in decimal form. Okay. And I took up a whole bunch of room to talk about complementary and supplementary. I took up my room to do my notes, so I'm going to put it over here in the margins. Let's talk quickly about complementary and supplementary angles. We had a little hiccup today when we were taking the quiz, how to remember the difference between them. So here's what you need to remember. Complementary angles add up to 90 degrees. Supplementary angles add up to 180. So if I have angle theta, and I want to find angle theta's complement, what I'm going to do is I'm going to subtract 90 minus theta degrees, or if my angle's in degrees, or I will do, if it's in radians, pi over 2 minus theta in radians. Depends on what I'm given, which of the two formulas I will choose. And if I'm looking for theta's supplement, I will do 180 minus theta degrees, or pi minus theta radians. Okay, so our instructions here tell us that we need to find the angle that is complementary and supplementary to theta using the same unit measure. So if I look at A, it says theta is in degrees. 73.26 degrees, it's in degrees. So I want my final answer, I want its complementary angle to be also in decimal degrees. So what I'm going to do is I'm going to take 90 degrees, but I've got a partial degree, so I'm going to do 90.00 degrees minus 73.26 degrees. And of course, you guys are going to pull out your calculators and do that math, which is great, but it's not going to help you when we do B. So you need to pay attention to what I'm about to do in A, because I'm going to explain it in B. So how do I subtract this by hand? I don't have my calculator. What do I do? Borrow. You borrow. And you've got to borrow all the way from the tenths place, or the tens place here. So we're going to make that an 8, make that a 10, and then we can borrow 1, right? And then we can borrow 1/10, like so. And we get the final answer quickly of 16.74 degrees. So this is the complement. And then you also have to find the supplement. And there's two ways you could go about it. It just depends on how your math brain thinks about it. My math brain thinks, well, if complements and supplements, they're 90 degrees apart, I could just add 90 to 16 and I could get its supplement. So that's one way you could go about it. Or you could go ahead and take 180 degrees and also subtract 73.26 degrees. I don't know why we're talking. No clue. All right. Either way, you will get the answer that you're looking for. So you can either add 90 degrees to the complement to get to the supplement, or you subtract the theta from 180 degrees and get the supplement. It's up to you what you'd like to do with that. But how do we go about this when we're doing math in degrees, minutes, and seconds, and you don't have the graphing calculator, and I won't show you how to do it with a calculator. I'll only show you how to do it by hand. When you prove to me and do it by hand, I'll show you how to do it with the calculator. Okay? So here I have theta in degrees, minutes, and seconds, and I want to find theta's complement. So I have 90 degrees, 0 minutes, and 0 seconds. I have no leftovers. And I'm going to find the complement to 25 degrees, 43 minutes, and 37 seconds. So you know I'm going to borrow, just like I borrowed from the other problem. But I'm not borrowing in base 10. I'm borrowing in base 60. So, or base 60. I don't know. A different increment. So I've got to come all the way from 90 degrees and borrow a degree. So I'm going to make that 89 degrees. And if I borrow 1 degree, how many minutes is that? 60 minutes. So now I have 60 minutes, and I need to borrow from 60 minutes. I need to borrow 1 minute. So that's 59 minutes. That'll give me 60 seconds. So I got to borrow all the way from the degrees. And so something you could write over here is 90 degrees is equivalent to 89 degrees, 59 minutes, and 60 seconds. Be good to know that. Same thing for 180 degrees. 180 degrees is 179 degrees, 59 minutes, and 60 seconds. Really important to know that if we're going to do math in degrees, minutes, and seconds. So let's figure this out quickly. I have the answer here, 64 degrees, 16 minutes, and 23 seconds. So that's the complement. Now you have to find the supplement. Again, your choice. You can either subtract your theta from 180, or you can add 90 to your complement. It's up to you. Quickly do that. Man, I'm having trouble. My brain thinks one thing and my hand writes something else. Okay, so I have 154 degrees, 16 minutes, and 23 seconds. Again, you either could have added 90 to get to the supplement, or you could subtract. Your choice. Okay, last 3 problems, and these are going to go quickly. So here, remember what I said at the top? When we're converting to degrees, minutes, and seconds, we're going to use this data. So it says here we're going to take 81 and 7,238 10,000ths of a degree, and we're going to write it in its a more precise form of degrees, minutes, and seconds. Here's what you do. You take 81 full degrees, and this is a part of a degree. It's not a full, it's like 72.38% of a degree if I wrote it as a percent. So what I'm going to do is I'm going to multiply this leftover portion of a degree times 60 minutes, and it's going to tell me what percentage of the degree, how many minutes that represents. So that's all we can do right now. So we get 81 degrees plus 428 minutes. So I've converted it to degrees and minutes, but I need it to be in degrees, minutes, and seconds. So I'm going to take this leftover portion, which is 42.8% of a minute, and I'm going to convert that. So that's 81 degrees plus 43 minutes plus 428 thousandths times 60 seconds. And we're rounding to the nearest second. And here's what we get. 81 degrees, 43 minutes, and I have 25.68 seconds. So I'm going to round that to 26 seconds. And this is an approximation because we rounded. So we're going to do a little approximately equals. Okay, guys, we got a boogie. So these last two are going to go quickly. It says for this next one, if theta equals 3 what? Radians. But I have to convert it to degrees, minutes, and seconds. That means first I have to convert radians to degrees. So I'm going to go 3 times 180 over pi degrees, which is 540 degrees over pi, which is approximately 171.8873 degrees. And then you will have to finish this out. Now, you should know how to do that. I'm going to tell you what the final answer is. It's 171 degrees, 53 minutes, and 14 seconds. So I want you to finish that problem out on your own so you can get there. Wait, real quick, I'm just going to write this last one out. This is going from degrees, minutes, seconds to degrees. So here's what you're going to do. You're going to do 19 degrees plus 47/60th of a degree, that's in minutes, plus 23 over, you tell me, I'm converting it from seconds to degrees, 36/100ths of a degree. And you'll plug that into your calculator and you will get just so you have it. Here, you got to know what your homework is. Ready? It's on Canvas. 2 through 28 even only, and it's 7.1a. And just so you know, on 2 through 16, only do A and B. Don't do C or D. And there you go. You can go now. Sorry.